Today, we're pulling back the curtain on the internet's hidden blueprint. I'm talking about a 7-layer model that makes all of our digital lives possible. Ready? Let's get into it. So, let's start with a question that, most of us never really stop to think about. You hit send on a message, you type a website into your browser, and poof, it just works. It feels like magic, right? But what's really going on? How does that data actually travel from your screen, maybe to a server halfway across the world, and then all the way back? Well, the answer lies in something called the Open Systems Interconnection Model, or as pretty much everyone calls it, the OSI model. The easiest way to think about it, it's like a universal rulebook, a common language that lets all kinds of different computer systems talk to each other. It takes this huge, complicated job of network communication and breaks it down into 7 separate, much more manageable layers.
So, to really get a handle on this journey our data takes, we need to look at the map. And that map is the 7 distinct layers of this powerful blueprint.
Okay, so here they are, all 7 layers, stacked one on top of the other. When you send something, your data starts its journey way up at the top, at layer 7, the application layer. Then it travels all the way down the stack to layer 1, the physical layer. That's where it gets turned into actual electricity or light pulses to be sent out. And then, on the other end, the receiving computer does the whole thing in reverse, going back up the stack. We're going to break down exactly what happens at every single stop on this trip. So what does each layer actually do? Let's break it down, starting from the very top, layer 7, which is right where your data kicks off the whole process.
All right, layer 7. This is the application layer, and it's basically our direct window to the network. Now, to be clear, it's not the web browser or the email client itself, but it's the layer that provides the protocols those apps use to talk to the network. You've probably heard of some of them, like HTTP for browsing the web or DNS for looking up website addresses. This is really the starting line, where our interaction kicks off the whole shebang.
Just below that, we've got layer 6, the presentation layer. You can think of this one as the network's universal translator. It's doing all the behind-the-scenes work to make sure data is in the right format. We're talking about stuff like character encoding, data compression to make files smaller, and, this is a big one, encryption and decryption for security. Its main job is to make sure that the data sent from one computer is actually readable by the application on the other end. Moving down to layer 5, we hit the session layer. I like to call this one the conversation manager. Its job is to open up a communication channel or a session between 2 devices. It keeps that channel open for as long as they need to talk and then closes it down neatly when they're done. It's also super handy for things like large file transfers. It sets up checkpoints, so if the connection drops, you can just pick up where you left off instead of having to start from scratch. Pretty smart, right? Okay, now we're at layer 4, the transport layer. Think of this as the quality control department of the whole operation. It takes all that data from the upper layers and chops it up into smaller, more manageable chunks called segments. This layer is all about how that data gets sent. It mainly uses 2 different methods, or protocols. There's TCP, which is super reliable. It checks for errors and makes sure everything arrives in order, perfect for an email where you can't have missing words. Then there's UDP, which is way faster but doesn't do all that error checking. It's great for things like video streaming, where losing a tiny bit of data here and there isn't a big deal, but speed is everything. Dropping down another level, we land at layer 3, the network layer. This layer is like the master logistician for the entire internet. It takes those segments from layer 4 and bundles them into something called packets. And this is where the magic of routing happens. The network layer figures out the best possible path for those packets to travel across the vast, interconnected networks of the internet to reach their final destination. And how does it do that? By using logical addresses. You guessed it, IP addresses.
Next up is layer 2, the data link layer. Now, if the network layer is about long-distance travel across the internet, this layer is all about local delivery. It's in charge of getting data between 2 devices that are on the same network, like your laptop and your Wi-Fi router. It takes the packets from layer 3 and wraps them up into something called frames. Then it uses a different kind of address, a physical address called a MAC address, to make sure that frame gets to the exact right machine on the local block.
And here we are at the very bottom, layer 1, the physical layer. This is where all that digital information gets, well, physical. It's the actual hardware, the cables, the connectors, the radio antennas. This layer takes those digital frames and turns them into a physical bit stream of 1s and 0s. It sends them out as electrical signals zipping through an Ethernet cable, or as radio waves for your Wi-Fi, or even as tiny pulses of light flashing through a fiber optic cable. So,
That's the whole journey, from top to bottom. But how exactly does the data get all bundled up and prepared for this trip? It's all thanks to a really clever process called encapsulation. The best way to picture it is like you're preparing a package to mail. As your data moves down from one layer to the next, each layer wraps it in a new box and adds its own label or header. So the transport layer adds its header, and now you have a segment. Then the network layer adds its header, and boom, you've got a packet. The data link layer adds a header and a little trailer at the end, and now you have a frame. It just keeps getting wrapped up until it's fully packaged and ready to be sent out as raw bits.
And you can probably guess what happens on the receiving end, the exact opposite. It's a process called decapsulation. As the data arrives and starts traveling up the stack, each layer unwraps the package, if you will. It strips off the header that was added by its twin on the sending computer, and then passes the contents up to the next layer and so on, all the way up until the original unwrapped data is handed off to the application.
All right, let's make this a little more concrete. How does all this theory play out when you do something super simple, like sending an email? So let's say Mr. Cooper hits send on his email. That message starts its journey down all 7 layers of his OSI stack, getting wrapped up, encapsulated, at each and every step. Then it gets transmitted across the network as a stream of ones and zeros. Once it reaches Miss Palmer's computer, it does the reverse trip, traveling all the way back up her OSI stack. It gets unwrapped, decapsulated at each layer, until finally the original, perfectly readable message pops up in her inbox.
Now, you might be sitting there thinking, okay, this is a neat little model, but why does it actually matter? I mean, does anyone really use this today? And that's a fair question, especially since the modern internet doesn't actually follow the OSI model to the letter.
Well, its biggest value today, by far, is in troubleshooting. When something goes wrong, and let's be honest, it always does, like you can't connect to the Wi-Fi, or a website just won't load, engineers use the OSI model as a mental checklist. It helps them isolate the problem. Is it a physical thing, like a bad cable at layer 1, or is it maybe an issue with the application way up at layer 7? This layered approach lets them hunt down and fix problems so much faster.
So yeah, it might just be a conceptual model, but the OSI model is still this absolutely essential map for understanding the invisible, super complex stuff that's happening every single second you're online. So the next time you send a message or load up a web page, just for a second, try to picture your data being wrapped, addressed, and sent on that incredible 7-layer journey across the digital world.